Hi, everyone. This is Derek Harp, the founder and chairman of the Control Systems Cybersecurity Association International, or as we call it, just CSA. CSA is a 501c6 nonprofit workforce development association dedicated to helping grow, support, and sustain the professionals charged with the cybersecurity of control systems. We're specifically talking about those systems that have pumps and valves and actuators, real cyber to physical moving parts, and control nearly every aspect of our modern connected industries. Thank you for tuning into the podcast. It is my hope you find it inspirational or motivating or revealing or informative, and perhaps at times even a little entertaining. Take care and be well. Hi, this is Derek Harp, founder and chairman of CSA and the host of the CSA show. And we'll get going today on a new type of event that we have not done before. I'm calling it an author spotlight. We have different spotlights you may have seen show up over the years. Well, this one is let's shine the light on authors in our midst. And who better to start this potentially new, event format style than with Andrew Ginter, who has been a long time supporter, almost as anybody can say they've been supporting CSA. Andrew's been there at the very beginning, and he supplies a lot of his time to initiatives at CSA, well beyond the fact that his company is also one of our oldest sponsors. And so I'm just, personally grateful to Andrew, setting aside everything Waterfall's done for us. Andrew's done a lot. He edits things, he reads things. He's a prolific giver of his time to the community and to projects that have merit. So, Andrew, please join us, and we will start talking about you and your books, specifically your newest one.
Thank you for that kind introduction earlier on. That's very generous of you.
Well deserved. No hyperbole there at all. Thank you for all the years and all the things you've done. So you've got the red book, and then the black book, and then the, golden black book, my favorite two color combinations. 527 pages. You've been publishing the first book in 2016, then the black book in 2018, and now this one in 2023. You've been busy.
Yes, to be fair, it's not quite that many pages. I actually reproduce, I think it's 54 pages of the black book in the appendix of the gold book. So
okay, got it. So how much of so we're talking 2016 to now? I know we're going to touch on some things, content in the book, sure, but also the process of book writing. And I would encourage you, if you're out there, if you're in the audience today, you've got a book in your head, but you just haven't ever quite written it. You can ask questions, Andrew, about the process as well. A lot of hours, a lot of time, and contributors. If you look in the front of his books, he thanks various people. A lot of people contribute to these sorts of things. And so if you're interested in the process, ask Andrew about that too.
Absolutely. To be fair, I think it's different for every author. I can speak to my process, but on the other hand, some information is better than none, I suppose.
Yeah, and I have read, I've seen authors quoted, some that churn out a book every single year or even more prolific, and others like, it took me 10 years to get this next book out. It certainly varies widely on the person and the genre and the type of book and all those sorts of things. But you've learned a lot, and I know we'll talk about it because of the sequence of doing this. And you and I've talked offline just about this third book. It's the child of the process of the other two books, right?
Yes, I try to apply the learnings. I don't know if you want me to go through the history of it.
Let's firmly introduce it. So everybody, this is the book. And, I think talk about sort of the evolution, because I know you learned some powerful lessons from the first books, and your goal with this is to make it more accessible, more useful to more people, and actionable. So yeah, why don't you talk about what is this book and maybe the process that led to it?
Sure. I put out the red book, was my first effort. I'd been trying to write something for many years, threw away multiple drafts, finally settled on this, and in hindsight made some mistakes. The feedback I got ranged from, Andrew, I disagree so fundamentally with your premise that I could not finish reading this thing, all the way to the other extreme of, I was talking to the CIO of a large power company, and asked, she actually came up to the booth and said, congratulations on the book. I said, thank you so much. I said, I have to ask, you have a copy? She says, yeah, I've got a copy. I says, so I'm the author. You have to tell me, have you read it? She goes, yes. She says, I did read it. I say, well, good, bad, or ugly, you got to tell me. What did you think? And I kid you not, she looks at the ground and she looks up at me and she says, Andrew, I'm not sure I know how to tell you this. It must have taken weeks of your life to write all this stuff down, yet everything you've written is obvious. What would possess you to spend so much effort documenting the self-evident? So from disagree so fundamentally I couldn't finish reading it to so obviously true it's not worth writing down, and everything in between. And so, I learned a few things. One is that experts disagree. There's no consensus in this industry. And the second is, nobody likes a critic. The subtitle of the first book, SCADA security is the title, subtitle, What's Broken and How to Fix It. What's broken? Those two words. I criticized a widely used approach to industrial cybersecurity. Nobody likes a critic. I thought I would show people the light and they would follow me to the light. When you criticize people, they get their shovels out and they start digging that hole deeper. That was, my apologies to everyone I offended. The second book, I said, that didn't work. Let's go to the other extreme. Let's document. I took a deliberately journalistic attitude. I said, let's document what the world's most secure sites do differently. They ask different questions, they get different answers. First they do this, then they do that, then they do that. If you see value in any of this, and it was fairly technical, if you see value in any of this, you pick and choose. I'm not going to tell you what to do. That didn't work the last time. So, the feedback I got was there's a lot of good stuff here. I didn't know a lot of this stuff. Where do I use it? When do I have to use all of this stuff everywhere? How do I figure this out? And in context, that's the same conversation I've had with people about IEC 62443 and ISO 27000 and the NIST cybersecurity framework. There's a lot of good stuff in there. Where do I apply it? How much of this should I be SL3 or SL4 or SL2, security level in 62443 terms? And so I paraphrase all that as how much is enough.
Really important theme that early in the book, you establish it and reinforce it. In my 13 years when I crossed over to this space, if there's anything that resonated with me, and I find the book to be, I will tell you everybody, if you're new, you might not know me, I don't shill anything. I recommend things I think of value. I'm finding the book very thought-provoking. I'm using the Kindle version. I'm writing or editing and putting in notes, but it's thought-provoking in other areas, other things that I'm thinking about for CISA and things that we could do. And this concept of it's clear now that one of the biggest challenges, we cannot do it all. And so frameworks and decision-making processes that lead to, we're going to do this and we're not going to do this and we're going to be deliberate about it. Anything that we're not doing, acceptable risk, or I forget the term you had in there for what that's called, residual risk or something like that. Yep. But whatever it is, we're deciding. It's not happening to us. We're in control, even the things we're not going to do, or even the things we're not going to get to. We're going to do that on a statistical, mathematical, quantified basis versus just like, oh gosh, I hope we did the right thing. Hope doesn't cut it, and that comes out in the book as well.
And so I had to finish this out. I really had three themes, goals for the book when I threw out the second version and started the third, because I did throw out several drafts. What I finally settled on was answer the question, how much is enough, and defend that answer. And so B, defend the answer. Adopt not a critical tone, not a journalistic tone. You figure it out, but come to the middle and adopt a prescriptive tone and say, here's the first thing you should do, and here's why you should do that. Now, if you have one of these, the next thing you need is this, and here's why that is. So try to produce a recipe, at least at a very high level, so that people can answer the question, what should I do? This is all good stuff. Where do I start? And so I try to answer that. And the third element was, there's something new in the world. It's called cyber-informed engineering. I'm not sure that what I'm advocating here is entirely aligned with cyber-informed engineering. It's something Idaho National Labs is driving, but so far there seems to be a great deal of alignment. And between the engineering perspective I try to portray in the book and what's happening at cyber-informed engineering, there's a new way of looking at the problem. And when I've finally figured out the new way and started sort of explaining it to people, the feedback I get is almost universally, what a good idea. It's not that any of the puzzle pieces are new, it's that there's a new way of fitting them together that has fewer gaps between them. And the feedback I get is, this just makes so much sense. Why is this new? Why haven't we been doing it this way for 20 years? And so that's the third sort of the security engineering, the engineering grade, that theme of a way of looking at the problem seems to be resonating. And those are my three goals.
Well, let's talk about engineering. It's in the title, and a fairly important distinction, and we have a lot of engineers here today. What's the deal with that? It wasn't in the previous titles, but it's obviously not only on the title, but a big piece of the approach of the book.
And as I said, it's something new in the world. I'm not an engineer. I'm a great fan of engineering. In hindsight, if I were still a young man, I'd say become an engineer. It's too late. I'm an old man on the end of my career. Let me talk cyber-informed engineering for a moment. It's 150 pages of strategy and 250 pages of implementation guide, and very detailed. And it does not use these words, but the way I think of cyber-informed engineering, the way I've heard it described colloquially, is as a coin with two sides. One side of the coin is cybersecurity. Teach the engineering profession, teach engineers about cyber risk, teach them about cybersecurity mitigations. There's nothing new there. Okay, we've been singing that song for 20 years. The other side of the coin is engineering tools for managing physical risk or risk to physical systems. And this, in a sense is new. I mean, the textbook example that I give on the back of my textbook is, and it's actually in, Security PHA Review as well, is where I got it from. The textbook example is a mechanical overpressure valve. If every one of us listening to the episode here today is a technician in a large old school coal-fired power plant, and we're responsible for a 6-story boiler, okay, massive device, full of course, steam that's boiling, 1 story of furnace under the boiler. Not just one boiler, we're responsible for 5 of these things, because this is over a gigawatt of power that we're producing. We calibrate the instrumentation, we replace the instruments when they're broken. We've got the gamma ray testers for the in situ corrosion determination. These boilers are our baby. If one of these boilers overpressurizes and blows up, we're dead. Every one of us is dead, and so is everybody else nearby. How would each of us like to be protected from that outcome?
Longer password, way longer password.
Yes. When there's a cyber attack on the PLC controlling the furnace, would we prefer a mechanical valve where if the pressure is too great, a piece of steel is forced against a spring, the steam escapes, or would we like a longer password in the PLC? So this is the classic example of an engineering mitigation. Where is the overpressure valve in ISO 27001, in the NIST cybersecurity framework, in NIST 853? Not even mentioned IEC 62443. Where is the overpressure valve? It's not there. These are all cybersecurity standards. The valve is a mechanical engineering mitigation for physical risk, and the engineering profession has many tools like this to mitigate physical risk. What kind of risk does it address? It addresses the risk of an earthquake crimping the outlet pipe on the boiler and overpressurizing the boiler. It addresses the risk of a hurricane coming in and messing with the settings on the furnace and overheating the boiler. It addresses these physical threats. And I know there are practitioners in the world who are applying this approach to mitigating cyber risk as well, the risk of a cyber attack overheating the furnace. But it's not being done universally. It's not being done systematically. It's being done in isolated spurts in different places. And so CIE is talking, look, the other side of the coin has been neglected. This is an opportunity to me to document and emphasize that side of the coin. Don't get me wrong. Nobody says, I'm going to pick engineering, I'm going to ignore cybersecurity. It's a whole coin. Okay, we get both sides of the coin. We've neglected the engineering perspective on that coin. And that's, one of my goals is to highlight that perspective, because it gives us a different way of looking at the problem. It gives us a different way of understanding the problem, a way that seems to be working for people.
Yeah, and you list sort of 4 things about what to do about risk in the book. 2 of them are, potentially lay some of it off with insurance, although that's not a catch-all in this category, and I think you covered that really well. We can come back to that. The other one is accept some of it, but the other 2, one is mitigate, and a lot of the cybersecurity software and technology stuff falls in that category, but there's a first one which is completely eliminated. And
Absolutely.
What you're talking about here falls in potentially the first or second bucket, but some of it's in the first bucket, which is complete elimination. That particular risk, you can't address all types of risks that way, but ones that you could, why not eliminate them completely? Is that valid?
Absolutely. And if you read risk textbooks, which I did, the textbook example in risk textbooks is actually a chemical plant. And it says, look, imagine that you have a chemical plant that combines two toxic inputs to produce a non-toxic output. Massive plant, millions of tons of input and output per year. If something goes wrong, you have the risk of a toxic release into the environment, into population centers nearby, into the plant, putting people in the plant at risk. You can try and mitigate that risk by having people carry, I don't know, breathers around with them all day long. Or you can eliminate the risk. How would you do that? Instead of combining two toxic inputs to produce your output, change the design of the plant so it consumes three non-toxic chemicals that can be combined into the same non-toxic output. Now, are no toxic chemicals at the plant anymore. A toxic release is no longer possible. It's gone. So this is the textbook example of changing the design of a system to eliminate risk. And there's a lot of that opportunity in the industrial space. I mean, not everyone can change the design of a power plant, but there are mitigations that can take consequences off the table, and there's mitigations that can address certain kinds of cyber threats really thoroughly.
Yeah, it's funny you should mention chemical. Did you see the blog article from Kelly Murray at CISA? It's talking about the CFAT is expiring, and so they assessed over 40,000 chemical facilities and found 3,000 of them at high risk. And now there's some time delay, so there's going to be even new chemical facilities that have things that in place, new chemicals, new processes they didn't have before. And so anyway, just assessing it as bringing it up to as a high level of a risk category. So that was just that blog was just yesterday.
Yeah, I haven't seen it, but something to keep in mind about CFATs, and for that matter, NERC-CIP. Something a lot of people don't realize with these standards. I'm digressing here a bit from the book, but something a lot of people don't realize is the mandate of the standard. In my understanding, the mandate of CFATs is to prevent primarily theft or misuse dangerous chemicals, like the chemicals involved in producing explosives or producing, I don't know, drugs. And so when I read CFATs, I said, there's not much in here on cyber. And it's because it was designed to have enough cyber in there to support the mandate of preventing theft and misuse of these dangerous products. The same is true of NERC-CIP. People don't realize this has a legal mandate to regulate the certain parts of the energy system in the United States. FERC has delegated to NERC a legal mandate to regulate cybersecurity for the purposes of assuring the reliable delivery of electric power to the nation's population. That makes sense, but it explains why if you search the online version of the NERC-CIP standards, you will not see the word safety in there even once. It's not that safety is not important. It's that NERC has no legal mandate to regulate safety. They have a legal mandate in those standards to regulate cybersecurity for the purposes of reliability. So when you're reading a standard, or especially when you're reading a regulation, regulations are particularly bad this way. They assume you understand why the regulation exists, and they tend to have a very constrained scope. So this is, people often say, well, what should I use as inspiration for my security program? Well, use NERC-CIP. Well, NERC-CIP doesn't say a word about safety. Do you have safety concerns? Yeah. Maybe you should use 62443, which in its preamble also says safety is out of scope. Well, maybe you got to look carefully at the scope of these things before you can understand, are they really going to apply, and to what degree can I rely on them?
Yeah, it makes sense. I mean, careful scrutiny is the name of the game these days with the unlimited time we all have. It's time consuming, but yeah, there's a lot to consume. So let's go back to the book. Let's break it down. 10 chapters, some fairly lengthy appendices. And so maybe just give a little bit of architecture understanding of how you set the book up that way.
Sure thing. One is obvious, introduction, phrase the problem. Two is, and if I may, sort of the style that I adopted, the feedback I got on the Red Book was that people liked chapters 1 and 2 the most. These were the ones where I introduced what is OT first, what is industrial control systems, and then later on, cybersecurity for industrial control systems. So I tried to write much of the book in that style, if that's what is working. I mean, most people never read the Red Book past chapter 2. This is the feedback I got. So I thought, if I want to keep people reading, I've got to give them this kind of content more. So chapter 1, introduces the problem, and tries to engage the imagination of the reader. Chapter 2 is an intro to industrial control systems. It's the one that was, chapter 2 in the Red Book. I cut and pasted a handful of pages, 1 or 2 or 3 pages out of the Red Book, and then embellished on that. Chapter 3 is introducing cyber threats and cyber risk. So really, chapter 2 is for IT people coming in or managers coming in who really don't understand the physical process. Let's introduce terms like HMI and PLC. Chapter 3 is really for, let's say, the engineers coming in, or again, managers coming in without a solid understanding of cyber risk, cyber attacks. What is all this cyber stuff? So I introduce the cyber stuff and point out how bad things are getting.
I like how you say at the beginning of those, if you're such and such, just skip ahead to the next chapter.
Absolutely. It's the engineers don't need to be told what an HMI is. You can skip it.
It's the challenge with all these, right? Is the audience of people addressing this category of issues are very mixed. They aren't from a particular file, just grab the next piece of knowledge. Well, you need this next piece of knowledge and you need that next piece of knowledge, and they're not the same because you're coming from totally different backgrounds. It's a fusion workforce, it's a hybrid workforce, whatever you want to call it. So it's courses of the same thing as books, right? And like, which audience am I writing to? And you're doing, and I think, a level best to write to more than one audience with the same book.
My audience is managers, but what I try to do in chapters 2 and 3 is sort of bring 2 large bodies of managers into sort of a common floor of knowledge so that we can use terms and have an intelligent conversation. And chapter 4 introduces security engineering or cyber informed engineering or engineering grade stuff. It looks at sort of the engineering perspective. Chapter 5 digs deeper into network engineering. And the connection between chapters 4 and 5 is very simple, but I wanted to highlight it. What happens when the mechanical valve goes and the boiler fails to blow up? Well, the good news is the boiler doesn't blow up. None of us die. Okay, so that's great. What else happens? We shut the power plant down because this is never supposed to happen. This is the last ditch safety, saving your life. Okay, if this failed, you're dead. So we shut the power plant down until we can understand what just happened here. That was not supposed to happen. Understand it, fix it, so it never happens again. This takes time. For all that time, the power plant is down and national security is at risk. What? National security? Where'd that come from? Critical infrastructure, the legal definition of critical, that word critical, is critical to the nation. And so we don't want to shut the power plant down. If a cyber attack is going to shut the power plant down, it's great that nobody dies. It's great that the environment isn't contaminated. But we didn't want to shut the power plant down. If we want to prevent that, we got to prevent the attacks getting in there in the first place. And so I talk about network engineering as engineering grade tools to prevent the propagation of attacks. And it's the murkiest, in hindsight, it's the murkiest collection of stuff in the book. Arguably, there's no strict definition of network engineering in there. I put a bunch of stuff together talking about how do you prevent the propagation of attacks. Is it all engineering grade? Maybe, maybe not. I also talk about managing reliability critical components on IT networks. None of that's engineering grade. So chapter 5 is network engineering, a hodgepodge of ideas around keeping the lights on, basically. It tends to be focused more on reliability than safety. 6 looks at risk. I argue that the traditional risk is consequence times likelihood, muddies the water, and I give us a different way to look at risk.
I got to say right there, I put a bookmark in page 95, cyber design basis threat, and it's got 95 has the equation on it, and I think a really important quote that I'll probably come back to later because I don't want to take you off what you're doing, but I think that's really important when you talk about it and you explain how that works, because I think we have all been thinking about likelihood and single variables in this equation, but it's more complicated than that. Or less complicated than that. I mean, depending on your perspective, but this is very thought-provoking for anybody, and not just people, in a particular role. I think anybody can think about this. This is like, okay, security for security's sake That's not the future. It's security in a prioritized way. It's security understanding, contextual cybersecurity. And that's what you're talking about. You're really understand, like, what are the variables?
And when chapters 7 and 8 address the question, how much is enough? I finally come to the main meat of the book. But in order to address the questions in 7 and 8, you have to have a model for decision making. You can't just, stick your finger in the air and say, this much is enough. And so chapter 6 kind of gives you the foundation. I'm sorry, it's got risk in the title. Most people think risk is boring. I suggest take a run at chapter 6. Let me surprise you. It's not as boring as you think it is. And if you look at the problem differently, I mean, engineers don't stick their finger in the wind and say, I think 2 overpressure valves is enough. They model the threat mathematically. They use, and I'm not a safety engineer. I haven't done the math. The math is involved. But I can appreciate the math because I've had it sketched out for me. That's all I do in chapter 6 is sketch it out.
Yeah.
And give you a model for making these decisions. 7 hits, what do you do about the pervasive network threat, which is ransomware, criminals using what used to be nation state tools just a couple of years ago. It feels like nation states coming after us in the hands of ransomware. Chapter 8 deals with sort of everything else. Once you've dealt with the network threat, how do you deal with everything else, with USB keys, with people walking in, with who knows what? And chapter 9 gives some scenarios, common questions with answers, common objections, and how to deal with them. 10 tries to wrap it up. The appendix, I've got an appendix in there for, again, cybersecurity people don't need to read the appendix. Managers, I would recommend glance through the appendix. It's called How to Hack Everything. It says, look, I have an antivirus system, so bad stuff can't get in. No, let me explain to you how to break an antivirus system. Oh, that's simpler than I thought. I also have, long passwords. Let me explain to you how to break passwords. I've got 2-factor authentication. I'm good. I've got zero trust. I'm solid. Let me explain to you how to break zero trust. Oh, shoot. What do we do? Go back to chapter 7. Okay, this is why I wrote 7 and 8. So that, this is why I put the appendix in there, so you couldn't just, from time to time, I run into people in the environment who have, let's call it, a naive belief in vendor claims. What's the vendor selling? They're selling whitelisting. They're selling firewalls. They're selling whatever. They're selling unidirectional gateways. Everything has its limitations. And if we're going to design defenses, we have to understand the limitations of the pieces of the puzzle. And that's what I tried to spell out again in 1-syllable words. And then the second appendix is, again, reproduced from the Black Book. The methodology in the Black Book still applies. And I didn't want to have, to make people who wanted to dig deeper have to go buy another book. And so I stuck the methodology of sort of controlling the flow of information into and out of systems, both on USBs and all that, into Appendix B. And so most of the book flies high and slow for managers, and Appendix B drops low and fast. But hopefully by then, the reader, even non-technical readers have got enough background to maybe keep up with some of what's going on.
Well, let's jump into cyber-informed engineering. And you've talked about it before today. Obviously, it's in the book. There's questions coming in. People are talking about how do you compare with cyber PHA. There's a great book by Sarah Freeman and Andy Bachman, which I've talked about in previous events. I recommend people read it, coming out of INL. Let's dwell on that particular area. I know one you and I've talked about before at different occasions, just between the two of us. Big believers in some important stuff there, and it's very tangential to what you're talking about, hence why it's in your book. Yep. But people are like, what does it mean? And is that all you're talking about, or it's a piece of what you're talking about? So a little bit of differentiation around those terms and how I compared to the cyber PHA will answer some of these questions as well.
Sure. So where to begin? So I introduced the term engineering grade, meaning approaches to protecting physical systems that are deterministic, that behave the same way all the time, whose failure can be modeled in a sense mathematically. There's, with most of these deterministic tools, there's a bathtub curve is what it's called for the failure rate. You have higher than average failure rate in the first year of use of the device because you're running into the potential for manufacturing defects. You've got, when the device is very old, an increasing failure rate because it's wearing out, it's rusting, it's whatever. The metal is getting fragile, who knows? And in between, you tend to have a lower than average failure rate for a specified sort of service life. This is deterministic, mathematically modelable. This is the goal for as much of our cybersecurity as we can on the engineering side. Not every threat has an engineering grade solution. To me, this is not a limitation of the methodology. This is an opportunity for innovation. If we can persuade people to look at the problem this way and to start demanding engineering grade solutions, community of innovators that exist in this space can look and say, well, concrete example, protective relays. For decades, protective relays were electromechanical, and they had to operate at very high voltages. And, so these things were very expensive. If you've got a relay that's going to detect an overcurrent condition at 500,000 volts, it tended to have, in my understanding, 10 or 12 activations in it. And then it wore out. You burned it out because it's operating in such a demanding environment. So how could you test if it worked? Send more current through and it would trip and the breaker would trip. Great, you've used up one of the activations. How often should I test if it still works? This was a big problem with these electromechanical relays. In the 1980s, I believe it was Schweitzer Engineering introduced the software protective relay that monitored what's going on in one place and triggered the breaker with a software signal. The breakers were now independent of the monitoring system. It was a thing of beauty. It dramatically reduced the cost of these relays. In hindsight, now what used to be electromechanical, unhackable devices that protected the equipment in the power grid from being burned out by lightning strikes and cyber attacks is now software. And cyber attacks can compromise the relay software. To me, there's an opportunity in the space right now for someone like Schweitzer to start, to develop and sell a chip as the relay. Instead of relay in software, do a relay on a chip. And to me, the logical chip is not design an actual chip. I mean, the firmware in the relay changes very slowly. Modern relays are, pretty stable. But you've got these things called field programmable gate arrays, which are like chips that can be reprogrammed with, enough physical intervention in terms of reprogramming devices and whatnot. So you don't actually have to go through the long, painful, expensive process of chip design. You can go through it much faster. You can, basically produce a chip much cheaper in an affordable way. But now you've got digital logic providing the function, the protective function, and that digital logic has no CPU in it. It has no software in it. It cannot be compromised. To me, that's an opportunity right now. You're asking, why haven't people built this already? Is any power utility out there asking for this? No, they're not. Why would any innovator build something that nobody's asking for? That's a failure looking at staring at you in the face. If we can provide the perspective, we can create demand for engineering grade solutions. We create opportunities for innovation to create solutions that don't exist today, that are engineering grade, that address cyber threats that cannot be addressed with engineering grade solutions today. To me, this is an opportunity.
So what's the tie to cyber PHA?
Introduce cyber PHA as an example of the body of knowledge that needs to come together in terms of, security engineering, cyber informed engineering. I believe it's a brilliantly written book. I love the book.
Oh, Jim McGlone's,
Jim McGlone, Edward Marzell,
yeah.
It's published by the ISA. You do have to pay for it. Before I read the book, the book talks about, I use the overpressure valve. That's their example. I'm using their example. It's brilliant. And they basically say, look, you've got OSHA, the Occupational Health and Safety Administration, requires that anybody operating a large safety critical industrial process requires them to do a HAZOP or a PHA, a process hazard analysis. It has different names in different jurisdictions. There you go. And they said, look, the output of the HAZOP very often includes a spreadsheet. And these guys say, look, you have to do this anyway. When you're looking at cyber, look at your HAZOP, look at your PHA, look at your spreadsheet. There's a row for every outcome that we're trying to prevent, the boiler exploding. Okay, there's a column for the outcome, the boiler explosion. There's a column for trigger events. How can it be triggered? It can be triggered if the output valve is crimped. It can be triggered if the furnace overheats. It can be triggered, in 4 or 5 different ways. And there's another column of mitigations. Well, how can you prevent the explosion if one of these trigger events occurs? Well, the human operator can get an alarm saying the furnace is too hot, the pressure is going up, and can press a button to turn off fuel to the furnace. That's a mitigation. You can have the mechanical overpressure valve. You can have other mitigations. And so it looks at that and says, look, if you have an undesirable outcome and any of the trigger conditions can be caused by a cyber attack, attack the PLC, overheat the furnace. Okay, if any trigger can be caused by a cyber attack and all of the mitigations are hackable, then you've got a problem. See if you can't insert an unhackable mitigation. In hindsight, I knew none of this before I read the book. And when I was done reading the book, I closed the book and I said, well, that's obvious. Of course, this is the right way to do this. Why haven't I known this since the beginning? It's brilliant. And that, in fact, was one of the inspirations for my book. I hope that someday I can produce a book where people will say, before they open the book, will say, I don't know how to do this. And when they close the book, go, well, that was obvious. Of course you do it this way. These guys are my inspiration.
Hi, everyone. This is Derek Harp, the founder and chairman of the Control Systems Cybersecurity Association International, or as we call it, just CSA. CSA is a 501c6 nonprofit workforce development association dedicated to helping grow, support, and sustain the professionals charged with the cybersecurity of control systems. We're specifically talking about those systems that have pumps and valves and actuators, real cyber to physical moving parts, and control nearly every aspect of our modern connected industries. Thank you for tuning into the podcast. It is my hope you find it inspirational or motivating or revealing or informative, and perhaps at times even a little entertaining. Take care and be well.
Two books have been mentioned. They're both highly recommend these. If you haven't read these yet, add these to your professional library. Again, get them online in a couple of different places, but valuable stuff and a great additional on the bookshelf next to Andrew's. Okay, so let's talk about the book. I mean, what's the reception been? I think it would start edging into a little bit about the book process itself. You've had the other two books, and you referenced quite bluntly today and in some writing that I've heard you say before that there was some interesting feedback, with the first book. What's this experience been like?
I've had limited feedback on the book because, it only came out 3 weeks ago. Most people haven't made it past chapters 4, 5, or 6. They haven't got into the meat of 7 and 8.
Yeah.
If you got into the meat, you can give me some feedback. The feedback I've had to the concepts, and I've been sort of prototyping these concepts ever since the last book. Some of this prototyping has happened on webinars that you've put on for me. If you recall, there was a webinar back in 2020, 2021, and, in the pandemic, where I talked about risk and basically went through some of the ideas that are now part of chapter 6. And bluntly, nobody showed up. If you want to kill your attendance, put risk into the title. Nobody wants to know about risk. They think it's boring. But I did get some feedback. I mean, that was one of the lessons. Don't put risk in the title of the book. No one's going to read it. But the feedback I've got on the concepts, and, I just came back from a tour of customer visits and, even regulator visits, regulators, other government authorities, guidance providers. As I said, the feedback I get is, what a good idea. Why haven't we looked at the problem like this before? And, credit where credit's due, I didn't invent any of these techniques. Okay. Most of what I invented is terminology. The puzzle pieces have been there since the beginning. What we're seeing with CIE and with this way of thinking about the problem is a new way to put the pieces together. And again, the feedback I got is, this just makes so much sense. Why is this new? So there's something there. And this is what I've tried to capture in the book, talking about the engineering perspective on the problem. The engineering perspective on the problem is, if I may, it's not even that I'm saying that IT security is wrong. Again, CIE positions it as a coin with two sides. We need the whole coin. But think about the process of doing industrial cybersecurity. In the beginning, and well, even today in a lot of organizations, who do we go to for cybersecurity advice? We go to enterprise security. There's 50 times, back of the envelope, 50 times as many cybersecurity experts in the enterprise space as in the industrial space. And so, when an engineering team in a lot of places needs to do cybersecurity, what do? They take their hat in their hands and they say, please, sir, to the enterprise security team, please, sir, can I have some cybersecurity? And the enterprise security folks look at that and go, oh, yeah, here, do this. And the engineers look back at what they got in their hat and they go, oh, that's awful. We can't do that. And it just doesn't work. And what I'm trying to emphasize here is that there's another way of looking at the problem. You ask the enterprise security people, worst case consequence determines how we should secure our systems. Yeah, that's obvious. What's the worst case consequence for a cyber attack on our power plant? I don't know. Things blow up? They don't know. The engineering team can go, no, no, no. We have mechanical mitigations that prevent things from blowing up. Oh, well, then how about, equipment damage? Well, we have protective relays protecting the equipment. What are the protective relays? They're software. Oh, so the software could be hacked. Now you've got a conversation going on between experts who understand the physical elements of the problem, understand the system we're trying to defend, understand how it's automated, understand, and the experts on the other side, who understand the security measures, who understand the threat. And now you've got, in a sense, equals coming together and contributing with, sort of a very high level sketched process. And each of them is making contributions that the other could not make. This is a new way of thinking about how this all fits together. And, it's become, I found it, the reaction has been very attractive. The IT people say, engineering's engaged. This is good. Let's, and I'm learning stuff. Let's keep doing this. And engineers going, I start to get it. The advice I'm getting isn't nonsense anymore. It's actually starting to make sense. And we're actually seeing, we're seeing people, instead of sitting on their hands going, this just isn't making any sense, they're going, this does make sense, and taking the first step and the second step. So good things are happening.
I'm sitting here thinking about the different sorts of people that are potentially here today listening, plus people that would receive you read the book. And we talk about already CCE and CIE and PHA and Secure by Design, which I'm going to ask about, which we haven't mentioned specifically.
And SecOT.
Yeah, it's a lot of different things. I don't know what the right analogy is, chessboard, layer cake. These pieces coexist together. One of them does not solve the issue. For instance, like you said, we can mitigate some of these risks with some hardcore traditional engineering solutions. It's not like we've solved all the cybersecurity issues. We've just taken that layer and we've eliminated some risks at that layer, right? But they're in the next layer of the cake. There's some risks that can't be done that way. As you said, they're going to have to do it this way. And we're not coming at this from the end users need to put valves over here. It may be that people in the secure by design phase, i.e. the people making things, also are going to play a new role in the future. They're going to produce things to begin with, to your point, with things in it. So you're talking at times with these terms to different stakeholders, not to one stakeholder with one solution, do this and this is fixed. This is a multifaceted thing.
Absolutely. And you need a lot of skills in the room. This is, part of what I point out, a new thing the world needs out of the engineering profession, or sort of a combination of engineering and enterprise security. When we do, security PHA, the spreadsheet, that mechanism for tracking safety issues and for evaluating safety issues is standard, is widely used. It's been used for decades. We don't have that on the cyber side. Go into a power plant. Where's the list of all of the worst case consequences of cyber compromise that we have to consider? I'm not sure. What is that list? Well, could be damage to equipment. Could we trip a cascading outage on the grid? I don't know. Well, who would know that? Well, maybe the protection engineers. There's knowledge that the organization, people in the organization clearly have this knowledge, trying to figure out who's got the knowledge to come together and produce this list of stuff we have to be concerned about. This is one of the new things that, to me, the engineering profession has to step up to. Instead of just doing that consistently, reliably, steadily for safety, we also have to do it for cyber. There was another one, but I've forgotten it. So
yeah, where does secure by design fit in this? That term, you've already mentioned some things that would be, in fact, I think fall under that, but we didn't use that term earlier. CISA's got a new secure by design program. Don't know if you could comment on that. Somebody asked you, that was in the questions that came in today. But that falls under this umbrella too, right?
Yes. I don't like the term secure by design because nothing is secure, but still marketing people love the term because it suggests that you've solved the problem. What secure by design means is you've considered security from the beginning of the design of the products that are used to automate your systems, to do everything from help drive your cars to the PLCs that are measuring and controlling your furnaces. It says that you've considered security from the beginning. It doesn't say that there's zero vulnerabilities. It doesn't say that it's invulnerable. This is why I wrote Appendix A, which is how to break everything, to give you an idea. I didn't even go through everything. I just went through 20 or 30 things.
Hey, wait a
just
minute.
to start
How
you.
about secure during design?
Well,
If
again, I
secure
don't.
by design is binary,
I would.
like it's been made secure during the design phase, and you're objecting to that, I do too. What about, hey, at least there was security being done while it was being designed?
Precisely, I prefer the word security. So if you can say designing with security,
Yeah,
something
yeah,
like that, much
yeah,
less sexy.
yeah, yeah.
So on the one hand, I don't like the term. On the other hand, yeah, we need that. Yes, please, more of that. But it doesn't solve the problem. It's one of the many pieces of the puzzle. It takes some of the really stupid mistakes off the table, but it doesn't solve the problem. No, in a sense, it raises the floor a bit.
Yeah, the end and downstream, the company that puts it into their operating environment. Oh, look at that. Risks 1 through 6 or whatever, arbitrary, have been eliminated. And well, now I guess we won't worry about 1 and 6. We'll worry about 6 through 82.
Yeah, it's good that hopefully the obvious mistakes have been taken off the table with secure by design. Something else that I like is secure by default. To me, it's in a sense, it's simpler. It says when you ship a product, turn on all of the security features. The vendor does this before shipping, so that when the customer gets it,
it's all off. You need
it's
to
all
implement
on.
it. It's on.
Yes.
Yeah.
Because if you say I have 99 security features and the customer gets it and says great, puts it in and it works, and they have to turn on the 99, they're never going to. So do it the other way around. Make people think about, I'm turning this off. Let me make a note of that. I might want to turn this back on because I had to do something here. There's consequences whenever I do something. Oh, I want to turn this off as well. Why am I turning all this security off? This is the kind of thinking that secure by default gives you.
Let's do a couple of slides. You got more questions. I'm going to come right back to them. Let's do a couple of supporting slides. If you want to get the book, so you can get a free copy by going to the Waterfall site. And we put a QR code there just now, right before the event on the left. And you can get a free copy of the book, the actual, this book. You could also go to Amazon and you can buy a hard copy or the soft copy or the Kindle electronic version as well, which is, I've been reading it in both formats depending when I travel. I like it on the electronic format. So anyway, Waterfall is giving books away right now if you go to their site and register, or you can get, for a limited time, you can get the e-version for, I think, $3. That's what I just did for Thanksgiving, as I was going to travel with my family and I wanted to keep reading it. And it was perfect on the electronic version for, for $3. So anyway, you got a variety of ways there to get your hands on it. So Andrew, let's go back to some of your Q&A. And so wondering, does the book have any specific examples of risks, cyber hazard assessments, et cetera, for the water, wastewater industry? Do you have any of your stories or analogies happen to hit that sector?
I do have a couple of examples in water and wastewater. One of the problematic examples is in that industry, a lot of utilities are small. One of the problematic examples, even in large utilities, the expectation in that industry seems to be that you buy, in a sense, large complex systems as a lump. Sometimes they're called skids. They show up on skids that a forklift can, it's a cabinet 6 feet tall and 3 feet wide and 3 feet deep, and it's locked. There's cables coming in, there's cables coming out, but in a sense, it's a black box, a system of systems. How secure is it? It's completely secure. That's what the vendor tells us. Can we open this up and figure it out for ourselves? No, you're not allowed to. It's a breach of the support agreement. And so trying to figure out what we have and how much trouble we're in. Are there engineering grade protections in there? I don't know. Trying to figure out, how much trouble we're in is just hard. That is something I've seen in the water industry. There are solutions in that space as well. I've seen water utilities. I give an example of analog signaling. I've seen water utilities using analog signaling for safety systems, and I'm going, whoa! I didn't think anyone did this anymore. Yeah, it's not done universally, but the most cautious of these systems. What does that mean? PLCs, 4 to 20 milliamp loops. This is how you send an analog signal between, let's say, 0 and 100%. You map 0 to 4 milliamps, 100% to 20 milliamps, and everything in between. You can get like 10 or 12 digits of precision sending these analog signals over fairly long distances physically within a plant or something. If you need to monitor a safety system without risk to the safety system, without sending it messages saying, what have you got for me? That could be misinterpreted, that could be a programming command instead of a query. I've seen water systems using analog signaling to monitor their safety systems. There's only a half dozen values that need to be sent. You need to buy a $500 component, for each end of the signal. So you don't want to send too many values in and out of here, but you can monitor your safety systems. You can integrate that status information into your main system without risk to the safety system, without sending it a message, without putting a firewall in there. The bad, sort of a hybrid, a controversial thing with water that I've done is I said, look, in a lot of small water systems, imagine you've got a town of 1,000 people. You've got a small water distribution system, small treatment system, small everything, out in the middle of nowhere. They can't plug into a bigger city's system because it's a half-hour drive away. Well, what do? You do your own. You've only got 1,000 households. Every household gives you maybe $1,000, $1,200 in the year for sewer and water service. You got a $1.2 million budget in the year. Where do you spend most of that budget? On people with forklifts and trucks that backhoes, digging holes in the ground, fixing problems, laying new pipe for the 6 new houses in the community. You don't have an IT person. You certainly don't have a cybersecurity person. You don't have an engineer on staff, much less an OT security person. Yet there's a spreadsheet. We have a spreadsheet that says remote access can save us $17,632.14 in the year because these 4 vendors don't need to come to the site 3 times each. And you do the math, and it's $17,000 we could save. Yeah. Do you realize that by opening up the remote access, you've introduced risk, and you really need to spend $250,000 or $500,000 a year on a real cybersecurity problem to address that risk? No, that's not in my spreadsheet. Your spreadsheet is a false economy. Okay, it's showing you the wrong conclusion. It shows you how much money you're saving. It doesn't show you how much money you should be laying on the table to address the risk you've just adopted. It's controversial. I know it's controversial, but I argue that small water systems need to be air-gapped. Air-gap those systems, guys. If you cannot pay for the cybersecurity for the risk you've incurred, you have no business incurring the risk. Nobody wants to hear about air gaps, but I think it applies to small water systems.
Yeah, let me see if I can rephrase that in a way. I was already thinking along the lines of what you were saying there was really important, because instead of there are people out there like, buy my product. Well, wait a minute, maybe not in some context. What you just said was to save $17,000, but to introduce much larger X factor of risk. Maybe you go ahead and you don't save that 17,000, and those 4 vendors do not have remote access. So you spent 17, you didn't spend 250,000, to use your example. That yes. might be the right math. You didn't buy a set of solutions or security implementations that, yes, you could, and they could be best of class, and they could do exactly what they're supposed to do and enable you to do what you were going to do, safely. Might not be the right choice for you. It's highly contextual based on budget, availability, and prioritization.
Absolutely. Another example, but I don't want to spend the whole time on water systems, is with water systems, there is often a surprising amount of physical security built into the system already. So, people often say, oh, with water systems, if you mess with the system, people could get sick. If you study the engineering of the system, a lot of the time, I can't say all of the time, I don't know how much of the time, I'm not an engineer. A lot of the time, it's not physically possible to make people sick by miscontrolling the control system. There's, a lot of physical mitigations in place. If you buy a skid that purifies water, comes out of the well, into the skid, into the water system, and you look at the piping, there is no pipe that bypasses the skid. There's no way to send untreated water into the distribution system. It has to go through the skid. What's the worst that can happen? You could damage the skid, you could plug up the skid, and the water could stop moving. You could run out of water, but you can't. There's physically no way to send contaminated water into the system. So this is the good news, is talk to the engineers. We need to engage the engineers to figure out what are the worst case outcomes, to figure out what fail-safes exist already, what new fail-safes can be inserted, and what we have to do about the rest of the cyber risk that we can't deal with using engineering grade tools.
I want to go back to page 95, which I referenced earlier in chapter 6. I stopped on this page and ended up writing quite a bit of different notes on different things on it. At the top, it's got the equation for risk. You're talking about earlier about risk not being being a term that, that has some hair on it. I think it's like the most important term that so many people need to work into their vocabulary. And this isn't me Derek, my pet theory, when I'm talking to so many different people now in the role that I'm in, all levels, board members down to entry-level people, the common thing is, how do I get more of this, or how do I get more of that, or how do I get by it, or how do I persuade the person potentially above me in the rung of decision making? And risk at the senior levels of organizations is the term they're using, have been forever. I'm not talking about cyber risk or OT cyber risk, but risk. And there's chief risk officers in some companies, and they manage risk in different ways. That's the language to learn, no matter where you are in the stack. Learn about risk and learn how to talk about risk, and learn, if nothing else, how does my boss and my boss's boss, how do they use the term risk? And if I understand how they use it, and I use it in a similar way, it's a wonder how some of my conversations may be more powerful. So you got this equation, then you talk about vulnerability and opportunity, and I just want to ask, it's interesting, not the same thing.
No, yeah, this is something that is, widely misunderstood in the industry. You read the 62443 standards, and by the way, just a plug for them, you'd have to pay to get hold of these standards. So it's hard to get hold of all 12 or 15 that have been published. It's a lot of money. Buy a membership with the ISA, and you can read the standards for free online. This is what I do. I pay $100 a year, and I have access to all the standards. The standards talk about vulnerability, and they use the word a lot. And when I talk to people at conferences, when I talk to people, what is a vulnerability? Anyone who's not studied 62443, anyone who's using it sort of colloquially, when you've got someone from enterprise security coming in, what's a vulnerability? It's a software defect that can be exploited by an attacker. Okay, it's like a buffer overflow vulnerability, it's like a hard-coded password. Yeah, those are all vulnerabilities. That's not how 62443 uses that word. Look at the definition of vulnerability. It's a more complicated definition. It basically means any way that a cyber component can be compromised. Any way. I could steal the password for it. Yep. I could, send a command to change the firmware. Yep. I could just connect to it and send it commands because it's not using an encrypted connection. Yep, those are all vulnerabilities. They're not software vulnerabilities. There's never going to be a patch for any of that. It's how the device is designed. This is part of secure by design. But here's the calculus that I see way too much. If risk is a function of consequence and vulnerability and threat, and I can, so it's one times the other times the other. If I can reduce one of these, if I can reduce vulnerability to 0, my risk goes to 0. Quick, patch everything. Now I'm invulnerable. This is nonsense. You can't. When you use the 62443, if you use the word the way they define it, it's all possible attack opportunities. Oh, well, there's no way to eliminate all possible attack opportunities. No, there isn't. You're never invulnerable. Oh, but people use the term the wrong way. I avoid the word vulnerability unless I'm talking about software vulnerabilities in the CVE catalog.
Yeah, well, I thought that was a really important distinction. And then I loved this paragraph, the cyber design basis threat, the CDBT. No cyber attack, this is an example that someone might use to define something. No cyber attack operating exclusively across the internet without the help of deliberately cooperating insiders in our organization shall be able to bring about a material safety incident, cause material damage to essential equipment, nor bring about any interruption to physical operations. That was a very powerful sentence. It's very carefully constructed, which is to say, what are we agreeing to? And there's going to be more and more. You talk about liability and insurance and lawyers' interpretation of terms. We're entering an age where liability is being spread around and being assigned to people who've never had liability assigned to them before. So wording is going to matter. And this is a careful definition. And one thing that it separates immediately is saying, look, we're not going to address on the same level playing field a nation state and Sally, who's disgruntled, who has authorized access today. That's a different threat, and not one to ignore. All the data that supports insider threat is potentially the biggest threat actor category, according to our annual report. It is the biggest threat actor category, but this statement clearly defines that differently. It's a carefully worded, instead of saying, we're going to solve all these problems, we're going to fix all this or whatever. No, we're going to get real specific how we define that.
Bear in mind, that example addresses risks across the network. It does not address the risk of an insider. Yeah. You would need a different design basis threat statement to address the risk of insiders. And the thing, one of the benefits of using design basis threat, which basically says, here is the the most capable adversary that we must defeat reliably. Everything above the line, we do what we can. Below the line, we defeat them reliably. It's a way to set the line, and you set the bar for a specific class of adversary or class of threat. And why is this useful? What's the alternative? What does 62443 tell us? It says you design your zones and your conduits, and every network zone has a security level. So if I have a network zone that is, controlling my power plant or my pipeline, and I worry about nation state grade ransomware coming in and, messing with my system and turning the lights out because I'm critical infrastructure. Well, that's a nation state grade adversary. You look at your definitions of SL1 through SL4, that's an SL4 grade attack. I must therefore protect my entire system to SL4. I assign SL4 as my target level. That's a really expensive way to do industrial cybersecurity. SL4 demands an enormous amount. With cyber design basis threat, you can set the bar very high for network-based attacks. You can say, yeah, there's nation state grade tools and attack techniques coming across the network in the hands of ransomware actors coming against me, but insiders just aren't that capable. I'm sorry, I'm not, pick an infrastructure, 1,000-person water utility. I'm not someone that a nation state is going to plant 3 sleepers in my organization 20 years ago and activate them today to go and sabotage my control system. That's just not going to happen. That threat is not credible. I don't need SL4 grade protection against insiders, but I do need it against the ransomware actors because they're pervasive. They attack everybody. And so this gives us a way to set different levels of protection for what we believe are credible threats. Now, some sites, I'm sorry, nuclear generators, they're at 4 across the board. They might even be at 4.5, whatever that means. But again, small water systems, shoe factories are different animals.
Yeah, I think that is the way forward, is to treat these in different mathematical. I like the science and math behind these things versus just hoping and wishing. And like you point out, nobody builds a bridge saying, well, I hope a strong storm won't blow the bridge over. It's engineers don't do that. They build systems and things that have lasted amazingly long times, not by accident, not by hoping and wishing, but by lots of careful design and applying the math correctly, so to speak. Let's wrap up a little bit then, talking about the book. People out there, other budding authors, what recommendation do you have for them? I mean, how hard was it? I mean, first one may be different than this one. How hard was it to produce it? Did you sit down on a weekend and bang it out, or did you spend, all of your time for 2 years doing it?
I burned a lot. I mean, I do this in my spare time, and most of the progress I make on these books are in my holidays. So I'm actually in the doghouse personally because I've burned most of my holidays for 4 years on writing this book. Writing it, throwing out the first version. You threw it out? You burned our holiday on something you threw out over and over again. So advice I have, I mean, I can only give you advice from my experience. I can tell you what I struggle with. I can't tell you what you struggle with. One of the things I struggle with is defining my audience and defining my goals. The first book I tried to write, the Red Book, before I wrote the Red Book, I thought what I need is a book to explain industrial cybersecurity. I need, the world needs more industrial cybersecurity. Back in 2013, 2014, there was almost nothing. There was very little out there. And so I said, okay, my audience is engineers who need to do cybersecurity, and I started writing the book. I said, oh, but I also need IT people who are coming to help out the engineers. And I expanded my scope and I put more material into the outline and I designed the outline. Oh, but someone needs to teach this stuff to students. Well, so now I need a textbook. So I need more introductory matter, and then I need examples. I'm going to need a solutions manual. I designed and got to the point where I said, I can't do this. It's too big. And I threw it out. And so time and again, I let the scope grow. I lost track of who my audience is. When I wrote the Red Book, when I finally managed to write the Red Book, it was after the first attack on the Ukraine. An article came out in IEEE Spectrum, the high end of sort of industry reporting. It's still not peer reviewed, not academic, but the high end of industry. And they said, look, this just happened in the Ukraine. What are the recommendations? we urgently need better intrusion detection in these substations. That's the wrong conclusion. And I said, well, how could you draw this conclusion? And I looked through and they quoted, substation intrusion detection vendors from one end of the article to the other. That's how you drew this conclusion. To me, it's the wrong conclusion. Yes, intrusion detection is important. Don't get me wrong. But I'm saying if that's the number one priority, the number one recommendation, how did the Ukraine attack occur? In my knowledge, they manipulated the HMI at head office, not in the substations, to send commands to the devices in the substations to turn off the flow of power. These are commands on like DNP3. How is intrusion detection going to prevent that? It's detecting, it's raising an alarm saying, hey, someone just turned the power off. At the same time, someone logged into the computers in the substation, presumably using the password that all these computers use because they're all the same. That's a guess on my part. Logged in and erased the hard drives. So you get an alert saying someone just turned the power off in this substation and someone just logged in and erased the silence. It's dead now. Next substation, someone just logged in and turned the power off. Someone just logged in and erased the silence. This is not adding any value. Okay, this is the wrong conclusion. Yes, you need intrusion detection. If it's going to add any value, you needed it back on the head office, not in the substations. And so I said, what am I going to do? Am I going to send a strongly worded, letter to the editor correcting the problem? This is IEEE Spectrum. Who reads letters to the editors? People are going to be quoting this article for the next 20 years. At that point, I threw out my draft of the Red Book. And I said, my goal is this reporter clearly has some technical knowledge and was missing a lot of knowledge about how industrial systems work and how cybersecurity works. And I'm going to write the shortest book that if that person read the book, they would not in good conscience be able to produce an article this wrong ever again. That was my goal. Concrete goal, imaginary person, but now I knew who I was writing for. And I knew what I thought they knew, what I thought they needed to know, and I could write. That's who I wrote for. That's what the Red Book was written for.
Well, I think that's great advice. I've got a couple of fragmented books in my head, and taking that advice would be helpful to me.
Yeah, so imagine, yeah, imagine the person, imagine the one person in the world that you need to read this book and what they know already and what you need to teach them. That was what I needed. I needed it for every wretched one of my books. I lost focus.
Andrew, thank you very much for all the things I mentioned earlier. Long-time service to the industry, long-time service to us over 8 years, and writing the books and using your vacation time. Thank you to your family for allowing you to do that, and hopefully you'll get out of the doghouse soon, unless you're writing a 4th book.
Yeah.
So thank you for all that.
My pleasure. Thank you so much, Derek.
Bye, everybody.
Hi, everyone. This is Derek Harp, the founder and chairman of the Control Systems Cybersecurity Association International, or as we call it, just CSA. CSA is a 501c6 nonprofit workforce development association dedicated to helping grow, support, and sustain the professionals charged with the cybersecurity of control systems. We're specifically talking about those systems that have pumps and valves and actuators, real cyber to physical moving parts, and control nearly every aspect of our modern connected industries. Thank you for tuning into the podcast. It is my hope you find it inspirational or motivating or revealing or informative, and perhaps at times even a little entertaining. Take care and be well.